You know that feeling, right? You're settling into your seat on a plane. Maybe there's that familiar rumble, or you hit a patch of turbulence, and suddenly that little voice in your head starts wondering about all those things you've heard about flying. Is this really safe? What's actually going on up front?
Mm-hmm. And for people really into aviation, or even just folks who fly a lot, these ideas, these myths, they can be really persistent.
Exactly. So today we're doing a deep dive. Our mission, to separate the fact from the fiction in commercial aviation. We've pulled together some fascinating stuff: pilot interviews, aviation reports, industry insights, all to tackle those myths that cause anxiety or, just confusion.
And the goal, really, is for you listening to walk away with a clearer picture. Maybe feel a bit less anxious next time you fly. And hey, maybe you'll even have some cool facts for your seatmate. We want you to understand why flying is actually celebrated as, well, one of the safest ways to get around.
Absolutely. Let's get into it. It's amazing how deeply some of these myths are rooted, isn't it? Even when all the evidence points the other way.
It really is. It taps into that basic human thing of fearing what we don't totally understand, especially being so high up, feeling kind of out of control.
Speaking of things that spark anxiety,
Yeah.
let's tackle the big one first. This idea that flying, that airplanes themselves are inherently dangerous. We've all felt that little flicker of doubt, right?
Right.
Especially if there's a delay or an odd noise. But you're saying the data tells a different story. Why does that fear stick around so much?
It's a great question because the reality is, statistically speaking, air travel is incredibly safe. Sources like ALEEP, IATA, VHR, these are major aviation safety bodies that consistently show it's much, much safer than driving. To put a number on it, in 2023, there was just one major accident for every 1.26 million flights. Think about that.
1 in 1.26 million? Wow.
Wow.
That's hard to even picture compared to an accident.
Exactly.
So what does that safety record actually mean for, for you listening, for the passenger?
It means you're wrapped in layers of safety. We're talking incredibly strict international standards for everything. Advanced tech in the plane itself, highly trained pilots who plan meticulously, who are trained to speak up if things feel rushed, constant air traffic control monitoring. And then there's the maintenance, rigorous, scheduled checks that keep these planes in top shape. It's a whole system.
A whole ecosystem, really.
Yeah.
It's not just the plane. It's the people, the procedures, the technology, all working together.
Precisely. Every single piece is geared towards minimizing risk.
That really does shift the perspective. Okay, now let's talk turbulence. I think everyone experiences this, right? And that myth that turbulence can actually, bring down a plane.
Hmm.
It feels plausible when you're bouncing around. I know I've gripped the armrest a few times.
Oh, absolutely. It's probably the most common fear, and it's understandable why you'd feel that way. But the fact is, turbulence is very rarely dangerous to the plane itself. Modern aircraft are engineered to withstand way more stress than turbulence throws at them. Think about those wing flex tests you see online. Like for the Boeing 777, they bend those wings to like 154% of the maximum expected load. They're built to flex.
154%.
Yeah.
That's way more give than I imagined. So what about different types of turbulence? Are some worse?
Well, the most common kind is usually linked to weather, like storm clouds. Pilots are really good at forecasting that and flying around it. But then there's clear air turbulence, CAT. That's the tricky one because it's invisible to radar in the eye. It just sort of happens.
And that's the one that might increase with climate change, I read.
Yeah, models do predict that. But again, pilots train specifically for handling CAT. It's a known operational hazard they prepare for.
So it's really like hitting a pothole on the road, just in the air.
Yeah.
I remember reading a pilot comparing it to that.
That's a great analogy. They talk about a startle effect with sudden CAT, but the training kicks in immediately. It's definitely very disturbing for passengers because you don't have that context or control, but the pilots genuinely have it under control.
Right. And the real danger then isn't the plane breaking apart.
Yeah.
It's something else.
Exactly. The actual risk is to passengers who aren't wearing their seatbelts. Between 2009 and 2021 in the U.S., there were about 146 serious injuries from turbulence, the vast majority. People thrown about because they weren't buckled in.
Wow. So keep your seatbelt fastened whenever you're seated. Even if the sign is off, just keep it loosely fastened. That's the key takeaway.
That is the single most important thing you can do for your safety during turbulence. Simple as that.
Okay, lesson learned. Next up, lightning. It looks so dramatic. You see pictures, maybe you see a flash outside the window. The myth is catastrophic. What's the reality?
It's fascinating, actually. Lightning strikes planes way more often than people think. Captain Al, a pilot we looked at, said maybe several times a year for him. But inside the plane, it's usually a non-event. Passengers might not even notice. He described it as maybe a white flash and a bang, kind of like dropping a teapot.
Dropping a teapot, that really takes the drama out of it. But how? Isn't lightning incredibly powerful?
It is powerful, but planes are basically designed like Faraday cages. The aluminum skin is a great conductor, so the electricity flows around the outside of the fuselage and exits somewhere else, often a wingtip or the tail. Pointy bits are common exit points.
And what about planes made with newer materials, like carbon fiber?
Good question. On planes like the Boeing 787, they bond thin metal mesh or strips into the carbon fiber specifically to conduct that electricity safely.
Okay, but the fuel. Everyone worries about fuel tanks in the wings and lightning.
Another common fear, but again, misplaced. Jet fuel, kerosene, isn't like gasoline. It's much harder to ignite, needing specific pressurized conditions. Plus, the metal structure around the tanks helps deflect the lightning away. It's all part of the safety design.
Could systems flicker off briefly? Is that a risk?
Systems might briefly go offline, yeah, but they usually self-reset, or the pilots can easily reset them. Captain Al said the biggest issue he ever had in 20 years from a strike was a demagnetized standby compass. Not exactly a critical flight system failure.
So after a strike, they just check things over?
Yep. Standard procedure is a post-flight inspection. They check the compasses, look for small entry and exit marks, maybe patch tiny holes. It's a maintenance item, not an emergency.
Right, that's reassuring. Okay, let's shift from the physics to the pilots themselves. There's this idea that they just flip on autopilot and, I don't know, read a book. That the plane flies itself?
Yeah, that's a really common misconception. Autopilot is a fantastic tool, absolutely essential for managing workload, especially during the long cruise portion of a flight. But pilots are actively involved in takeoff, landing, climbing, descending, and any complex situation. They're constantly monitoring everything, the systems, the weather, the route, ready to take over instantly. One pilot described it as automation limiting fatigue, so we can focus on the important stuff when it pops up.
So it frees up their mental energy for the critical thinking, the monitoring.
Exactly. Full gate-to-gate automation. That's still way off in the future. Today's flying is very much human-managed, human-monitored. Professional flying is described as systematic, carefully choreographed, meticulously planned. Pilots brief everything. They talk through maneuvers.
They're not just making split-second decisions all the time.
Not usually, no. Those quick decisions are reserved for true emergencies: smoke, fire, sudden loss of pressure. Most of the job is about careful planning and execution.
Makes sense. Okay, here's one that causes a lot of debate. Airplane mode. The
Yeah.
myth. Turn your phone off, or the plane might crash. True or false?
Mostly false, thankfully. For modern aircraft, forgetting to switch to airplane mode is extremely unlikely to cause a crash or seriously mess with the plane's systems. Most aviation experts basically say it's not a darn thing for actual flight safety.
Okay, so if it's not going to crash the plane, why the rule? Why do flight attendants still tell us to do it?
There are a few real reasons, actually. The main one today is potential interference with the pilot's headsets. Cell signals can cause that annoying clicking or buzzing sound, which could, make it harder for them to hear air traffic control, especially during critical times like landing.
So it's about clear communication for the crew. What else?
Well, historically, back in '91, the FCC banned in-flight calls because of concerns about messing up ground-based cell networks. Imagine thousands of phones switching towers at high speed.
Right, that could cause chaos on the ground. And I've read something about 5G recently. Is that related?
Yes, that's a newer and more specific, legitimate concern. Certain 5G frequencies can interfere with the radar altimeters on some, especially older, aircraft. This is mainly an issue during landings in bad weather using instruments. Regulators and airlines are actively working on solutions for that specific problem.
So for the passenger, the main issue is probably just a dead battery.
Pretty much. Your phone works really hard trying to find a signal up there, so it drains the battery fast.
So it's more about courtesy to the pilots, legacy rules, ground networks, and that specific 5G issue.
Yeah.
But not imminent danger for most flights.
That sums it up well. If it were truly critical for safety, they'd likely collect phones before takeoff. It's more courtesy, not catastrophe.
Got it. Okay, what about one that feels like pure nightmare fuel? Can you actually open an airplane door mid-flight?
Okay, deep breath, everyone. At cruising altitude, it is physically impossible, period. The pressure difference between the inside cabin and the outside air is huge. Maybe 8 pounds per square inch more pressure inside. That pressure pushes the door outwards against the frame with immense force, thousands of pounds of force. You physically cannot push it open against that.
Like a giant suction cup holding it shut.
Exactly. Plus, the doors are usually mechanically locked by the flight crew and only unlocked near the ground.
But you said at cruising altitude. Is there a time when it could be possible? We saw that incident last year.
Right, that's the crucial distinction. During descent, as the plane gets lower, the pressure difference decreases. In that Asiana incident in 2023, the passenger managed to open a door when they were very low, around 700 feet from landing. The pressure had equalized enough.
Still terrifying for those on board, I imagine.
Oh, absolutely. 12 people needed medical attention for hyperventilation, but it highlights it wasn't a mid-flight, high-altitude event.
And what happens if someone tries to open a door, even if they fail?
Even trying is a very big deal. Flight attendants are trained to restrain passengers if needed, sometimes using flex cuffs. They also identify able-bodied persons to help, and legally. Attempting to interfere with a flight crew, including trying to open a door, is a serious federal crime. Huge fines, potentially years in prison, getting on a no-fly list. Don't do it.
Definitely not worth trying. Okay, another visual from movies. Fuel dumping. Streams of fuel coming from the wings. Is that a normal thing planes do?
Absolutely not normal or routine. Fuel dumping is almost exclusively an emergency procedure. It happens when a plane needs to land much sooner than planned, maybe a medical emergency or a significant technical issue right after takeoff.
Why do they need to dump fuel in that case?
Because planes typically take off much heavier than their maximum safe landing weight. Landing puts different stresses on the aircraft structure. If a plane has to land immediately after taking off, it might be way too heavy. Dumping fuel gets a weight down to a safe level for landing. It avoids potential damage to the plane and the need for lengthy, costly overweight landing inspections.
And what about the environment? Is all that fuel just raining down?
That's a common concern, but the fuel is released at high altitude and atomizes it turns into a fine mist that largely evaporates before ever reaching the ground. It's designed to disperse safely.
Good to know. Okay, let's move into the cabin experience, comfort and health. First up, the classic joke. Airline food is always terrible. Still true.
Well, the joke persists, but the reality has changed quite a bit. While it might have been grim decades ago, in-flight dining has significantly improved. Especially if you're flying in premium cabins, you can get some genuinely gourmet options. Airlines partner with chefs, cater to dietary needs. It's not always bad.
So why the bad rap then? Why does everyone still kind of expect it to be bad?
I think it's partly the constraints. You've got limited galley space, food prepared maybe days in advance, reheating challenges at altitude, which dulls our taste anyway, and partly an expectation gap. People compare it to a restaurant meal, which just isn't feasible in a metal tube at 35,000 feet.
So appreciate the logistics, maybe.
Exactly. Getting any kind of hot, reasonably palatable meal served safely under those conditions is actually quite an achievement.
Fair point. Now, a big health concern, especially lately, recirculated cabin air. The myth is it's full of germs and makes you sick. My gut reaction is probably.
That's what most people think, but this is a huge misconception. The air quality on modern planes is actually remarkably good. They use HEPA filters. These are hospital-grade filters that capture over 99.9% of airborne particles, including viruses and bacteria. And the air isn't just recirculated, it's constantly mixed with fresh outside air, and the entire cabin air volume is replaced every 2 to 3 minutes.
Every 2 to 3 minutes. That's way faster than in an office or my house.
Exactly. The air itself is often cleaner than many indoor environments we spend time in daily.
Okay, so if the air is clean, where do the germs come from? Why do people sometimes get sick after flying?
It's not the air system, it's proximity and surfaces. You're sitting close to other people who might be coughing or sneezing. And think about all the things people touch. Tray tables, seatbelt buckles, armrests, lavatory doors. Those are the real culprits for germ transmission.
Right. So what can you do practically to protect yourself then?
Simple stuff, really. Get your vaccines, flu, COVID, RSV. Carry hand sanitizer and use it often. Use disinfectant wipes to clean your tray table, armrests, buckle. Maybe wear a mask if you're concerned or it's a crowded flight. Basic hygiene goes a long way. Much more effective than worrying about the HEPA filters.
And what about those other weird air myths, like pilots cutting airflow to save fuel or even reducing oxygen?
Both completely false. On Boeing planes, pilots basically have no control over the airflow mix. It's set by the manufacturer. On Airbus, there might be like a high normalo setting, but the fuel savings on all low are tiny, and passengers wouldn't notice the difference.
And reducing oxygen, that sounds dangerous.
It would be incredibly dangerous. That's called hypoxia, and it causes confusion, nausea, headaches. Pilots would never do that. They breathe the exact same air as the passengers. The cabin pressure is automatically maintained at a comfortable level, equivalent to maybe 5,000 to 8,000 feet altitude. The oxygen levels are perfectly safe.
Okay, good to debunk those sinister ones. Now, for our last myth, and this one might actually surprise people, the idea that the tap water on planes is safe to drink.
Yeah, this is the one where the advice is actually maybe be cautious. Several sources, including a past EPA report and flight attendant associations, have raised concerns that the water tanks and systems on planes aren't always cleaned frequently or thoroughly enough. Some call them nasty. There are anecdotes of ramp workers saying they wouldn't drink the water from the plane's tanks.
Really? Even though it's regulated?
It is regulated by the EPA, yes, but some groups feel the enforcement or the standards maybe don't go far enough to guarantee cleanliness consistently across all airlines and planes.
So what's the bottom line for us passengers? What should we drink?
The safest bet is just to stick to bottled water or canned drinks. If you want coffee or tea, maybe grab it in the terminal before you board or after you land, just to be extra safe. It's probably the one area where a bit of extra caution might be warranted based on the available information.
Wow, okay, so maybe skip the onboard tap water. Good tip. Well, we've certainly busted quite a few myths today.
We really have. And the main theme, I think, is clear. Flying is incredibly safe. So many of our common fears are based on misunderstandings or outdated ideas. From the way planes handle turbulence to the quality of the air you breathe, modern aviation is just a marvel of engineering and rigorous procedure.
Absolutely. And hopefully understanding these facts helps you feel a bit calmer, a bit more confident next time you fly. Knowing what's really going on can genuinely improve the whole experience, maybe even let you appreciate the journey more.
Definitely. You can see the layers of safety, the professionalism of the crew, the robustness of the technology. It's all there.
So here's a thought to leave you with. In this age of information overload, being able to tell fact from fiction, myth from reality is such a crucial skill, not just for flying, but for everything. What other pieces of common knowledge in our lives might deserve a closer look, a deep dive like this one?
That's a great question. Keep asking, keep learning. Use the knowledge you gained today, maybe share it. Continue seeking that informed understanding.
Until next time, stay curious.